Getting now into the more challenging aspects of the chapter, which is, as it typically is in this class, when we start introducing graphs and we start introducing numbers. Okay, so let's think about let's think about a monopoly that faces this demand curve. Okay, so the demand curve is going to be subject to basically two variables, price and quantity demanded. So I'm just going to create a demand curve here, nice simple one. All right, so just a nice linear demand curve here. As the price goes down, quantity demanded goes up. All right, exactly what you would expect to see. We could graph this demand curve if we needed to. In fact, we may do that here in a bit. So this is the demand curve that we have. And now let's think about the monopoly. Okay, here's the key thing to recognize. And if you're watching me right now, you probably want to write this down. The key thing to recognize about a monopoly is if they lower the price, okay, they're able to sell more, and if they raise the price, they have to sell less. So here is the deal. When they are choosing a price, they are choosing a price for all consumers. Okay? We will reduce that constraint when we get into the next lesson that we have for next week. But for now, we're going to make the assumption that a monopoly chooses a price, one price, for all consumers. So if they want to sell 2 units, they can sell it at a price of $9. But if they want to sell 3 units, they have to charge all of the consumers $8. Okay? That's the key thing here to recognize. They're choosing price and quantity simultaneously. So now that we have demand, all right, which is sort of outside of the firm's control, we can think about their revenues. So here will be their total revenues at each different price level. And I'm just going to find this by taking price and multiplying it times quantity. Easy enough. Okay? And what you see here is, again, I'm just getting this by multiplying price times quantity. At $8, they sell 3, so they get $24 in revenues. So what you'll see here is, as the price goes down, total revenues go up, but eventually flips and actually starts going down. That has to do with the elasticity of demand, which you may remember from the last testing cycle. It's one of the harder ideas, that basically demand, when it's linear, still has periods where it's inelastic and periods where it's elastic. And that's ultimately what's driving this effect here. Okay? So basically what we can assume is happening is for this period here, where more quantity means more revenue, basically the effect is the percentage change in quantity is greater than the percentage change in price, which means it's elastic. All right? The demand is elastic here. So as they raise the price, they're going to lose quantity, basically what's happening here. And the extent to which they're losing quantity is so great that raising the price, moving this direction, would actually reduce their revenues. Okay? But when prices are very low down in here, the percent change in quantity is less than the percent change in price. So now if you're sort of moving up the table here, if they decide to raise the price, the change in quantity in percentage terms is not all of that extreme. So as they raise the price, they're also able to raise their total revenues. I'm not going to test you on that for this testing cycle because you've already been tested on that. But that's the logic of where this is coming from. It has to do with the elasticity of demand. So now we're going to add another component to our table, marginal revenue. So marginal revenue is the percentage change in total revenue divided by the percentage change in the quantity. Okay? Now when we were thinking about perfectly competitive firms, the price and the marginal revenue were always the same. You don't need to write this down because you've already been tested on it, but you might recall that when we graphed the perfectly competitive firm, we set it up this way, where the price was constant, the demand that the individual firm faced was constant, and thus the marginal revenue was constant. What that means is if I'm selling soy and I can always sell soy for $1, well then the marginal revenue will always be $1. If I want to sell one more unit, I get one more dollar. If I want to sell another unit, I get one more dollar. That is constant over time. But here's the thing, for a monopoly that's not constant. If they want to sell one more unit, they have to drop the price for everyone, okay? So what that means is the marginal revenue is not the same as the price, all right? If they want to go from $8 to $7, you see, it's not like they're just gaining $7. No, they're having to reduce the price of all consumers from 8 to 7 in order to get that extra unit. Tricky conceptually, but mathematically you'll see this is not so hard. Okay, so as we go from quantity of 0 to 1, we're adding $10 in revenues here, so the marginal revenue is 10. As we go from 1 unit to 2 units, we gain $8 in marginal revenue. You can already see here what's happening. See, as the price drops from 10 to 9, marginal revenue only goes up by 8. It's only 8. All right, so what that means is when you add the second consumer, you're gaining 9 on that consumer. So you're gaining $9 from that second consumer, but you're losing $1 from the first consumer because you could have charged them 10. All right, so you're losing 1 from the first consumer, gaining 9 from the second consumer. On net, that means you're adding $8 to your revenues. All right, so that's the logic of how this is applied. So continuing on, this is 6, 4, 2, 0, and negative 2. And recall, this is the percentage change in total revenue divided by the percentage change in quantity. What makes it mathematically pretty easy here is the quantity is just changing 1 every single time. Okay? So we're going to get real accustomed to dealing with this because we're going to use this to graph out demand and marginal revenue. Okay? So here's what this looks like now when the individual firm is thinking about demand and revenues. Okay? So demand, if we want to graph this out here, try to do my best to draw this well. Not always the easiest. All right, so I'm just trying to draw this demand curve, and then I'm going to draw marginal revenue. You need to see where this comes from in order to conceptualize it. Okay, so we're basically just going to take this information that we already have that's in a table and turn it into a graph. All right, and these graphs are what we're going to typically be dealing with in these problems, kind of like what we saw with perfect competitive markets, right? All right, so I'm just going to draw out this demand curve. So you can see at a quantity of 1, we have a price of 10, and then it's just going to be linear from that point on. Try my best to make this look linear. It's not always the easiest. Okay. So there's my demand curve. So that demand curve is going to be perfectly linear here. It's going to be a straight line. So as the price goes down, the quantity goes up in this linear fashion, which is exactly what we got over here. Okay. On the other side of the market we need is our revenues, specifically our marginal revenues, because remember, rational decisions are made at the margins. Okay. So marginal revenue is going to be what helps determine what these firms decide to do. So marginal revenues, as it turns out, are going to start at the same place. They'll start right here. Okay. but then they will be twice as steep. That's a nice rule of thumb to remember, that marginal revenues is always twice as steep as demand. So it's basically just going to pivot out here and have twice the steepness. So at we're going to start out here at a price of $10. We had one consumer and also $10 in marginal revenue. All right, so that point is going to be the same for demand and marginal revenue. But at a quantity of 2, the marginal revenue is 8. So you can already see that twice as steep effect is going to occur. Quantity of 3, the marginal revenue is 6. It's going to be here, and so forth. I want to make sure you guys see the logic of where these values come from, and then eventually it's actually going to go negative here at a quantity of 7. So this marginal revenue curve is just the quantity demanded and marginal revenue connected. It's graphing those two things. We're taking marginal revenue, which is in dollars, and putting it up here on this graph because we know the quantities and we know essentially the dollar values, okay? So at a quantity of 5, the marginal revenue is $2. That means if you sell the 5th unit, the company's going to add $2 to their total revenues. That's what that is telling you, okay? So we've got demand and we've got marginal revenues here. So now we can connect this now to the firm's costs, okay? And this is where you're starting to combine a bunch of stuff together at the same time. Everything you're seeing up here is thinking about the consumers. It's not thinking about the cost at all. If I ask you, is this firm profitable? You have no way of knowing because we don't know anything about the cost. Maybe they can produce the items for a penny each. Well, that'd be great. They'd probably get a big profit. What if it costs them $100 each? Well, there's no way they can make a profit then. So we need to connect the demand side to the production side for this market, okay? So let me erase everything. We'll start fresh. So you're going to kind of prepare yourself here for one of those big tables like we had in the past. So I'm going to try to make this, again, sort of like the last example where the numbers are pretty simple, right? Low numbers, so we don't have to get wrapped